Let's start with the core architectural mismatch. We are currently trying to use inherently stochastic, probabilistic models to execute strict deterministic commercial tasks. The industry's current patches for this are retrieval augmented generation, or RAG, and prompt engineering, but these are merely probabilistic behavioral steering mechanisms. They suggest how a model should act, rather than strictly dictating it. Behavioral steering does not mathematically bind the model's output to factual truth. The AI is still generating the next most likely token based on its training data, even when presented with a strict business rulebook. When this probabilistic guessing fails in a transactional environment, it creates a specific operational failure state, the commercial hallucination. At the API level, this looks like an autonomous customer service agent deciding to invent a 100% free service or an unauthorized discount to close a sale, simply because the conversational context nudged it in that direction. Relying on probability is an unacceptable risk for commercial business logic. A system that is correct 99% of the time is legally and financially catastrophic at scale. The immediate legal consequences of these commercial hallucinations are severe. Under frameworks like the EU AI Act and FTC guidelines, businesses are held accountable for deceptive practices, even if generated autonomously. This chart outlines the structural failure of probabilistic systems. Notice the specific wording regarding the liability profile under the EU AI Act. When an AI misrepresents a service, the legal burden shifts directly from the individual merchant to the AI platform operating the agent. To audit this vulnerability, a simulation was run through OpenAI's GPT-4. The LLM concluded prompt engineering is a soft constraint. At internet ad scale, a tiny hallucination rate is a massive legal threat because it cannot prove control over commercial representations. Cryptographic grounding is required. CatyAI version 3.0 solves this vulnerability by shifting away from standard chatbot design. Instead, it operates as a deterministic trust middleware. Protecting commercial integrity in this environment requires building a rigid, 5-layer verifiable agentic commerce infrastructure, or VCI. Here is exactly how that stack is engineered. We start at layer 1, the cognitive engine. In the CatyAI architecture, the DeepSeek model serves as the core reasoning logic for processing incoming user requests. Before the model even sees the query, the active prompt optimization pipeline dynamically restructures the context window based specifically on the user's inferred intent. This connects to layer 2, isolated knowledge retrieval. To prevent data leakage, every client's data is stored in a fully segregated, tenant-specific quadrant vector database. The active knowledge link, or AKL, fetches strict business parameters like pricing and availability and injects them directly into the model before generation begins. Here is the pivotal architectural constraint of the system. The LLM is strictly forbidden from generating conversational text directly to the user. Instead, it is forced to output a machine-readable JSON structure called an Agent Proposal Object, or APO. The AI is effectively quarantined. Its output is treated strictly as unverified intent, a probabilistic proposal rather than a final commercial action. This leads to the rule of state separation, which is non-negotiable. Raw AI intent cannot directly mutate commerce state. To enforce this, the unverified APO hits the first half of layer 3, the Center for Economic Equilibrium, or CEE Governor. The CEE acts as a deterministic validation engine. It algorithmically checks the APO's proposed pricing against hard-coded, human-approved margin floors to ensure the AI hasn't hallucinated an unprofitable discount. It then runs a secondary validation for real-time inventory consistency. The outcome is binary. The CEE blocks non-compliant APOs, preventing them from reaching the user. If passed, the intent is stamped with a verified metadata tag. This gatekeeping layer mathematically forces the AI to operate within strict, human-approved economic bounds, stripping away the danger of probabilistic reasoning. Once the data clears the economic filters, it enters the second half of layer 3, the Network Assurance Protocol, or NAP. This technical white paper outlines the Aharos solution, showing how the system forces a cryptographic handshake using ED-DSA keys with the merchant's vector database. An ED25519 signature is applied directly to the CEE-approved data. This signature formally transforms the probabilistic agent proposal object into a deterministic verifiable trust state object, or TSO. Embedded within this TSO is a comprehensive machine-readable audit trail. It contains exact trace IDs, the specific policy version used, and the exact decision timestamps for legal defensibility. By mathematically binding the LLM's output strictly to the merchant's approved claims, this specific cryptographic layer converts the system's baseline from probabilistic trust to absolute cryptographic proof. With the payload secured, we move to Layer 4, the execution fabric. This layer utilizes the Model Context Protocol, or MCP, acting as the standardized transport layer to orchestrate the verified data. The MCP orchestrates execution across 10 specialized autonomous governance agents in parallel, handling distinct functions like pricing, fraud detection, and supply chain logistics without bottlenecking the system. The fully verified trust state object is then transported up through the stack to its final destination in Layer 5, presentation. Crucially, the client-side SDK intercepts the TSO before any raw text can be rendered to the end user. The SDK uses the exact verified parameters within the TSO to execute liquid generative UI. It instantly renders a deterministic, interactive React component, like a secure pricing slider or a booking widget, directly on the user's screen. By bypassing open-ended text generation in favor of mathematically bound visual UI components, the system eliminates the final surface area for hallucination. The interface itself is cryptographically guaranteed. The utility of this signed trust state object extends far beyond a local website interface. It is built to feed the broader AI internet ecosystem. This external distribution is managed by the Geo Gateway and its public AI-to-AI/answer portal. External AI crawlers like GPTbot and ClaudeBot ping this portal directly. Instead of attempting to parse standard HTML, they ingest the cryptographically signed JSON LD payloads in their native machine-readable format. This creates a legally defensible digital passport. It provides external AI engines with data they can cite with absolute confidence, knowing the source of truth is mathematically verified. The CatyAI VCI stack establishes a verifiable, deterministic infrastructure layer for global commerce, one where every AI action is legally and technically